Hello everyone, and welcome to my first official YouTube lesson. Today we're going to be spending a little bit of time looking at something called the Remainder Theorem, which is the first lesson in Unit 2. And we're going to start by first looking at a little investigation. I'd like you to think back to elementary school when you learned about division. And we're going to try and remember how we can divide 753 by 22. So in elementary school, you would have been taught that to do this question, you need to look at the the largest place value digit in 753. So we're looking at 7 for 700. And we're going to ask ourselves, how many times does 22 go into 7? Evenly. And we actually can't divide 7 by 22 evenly. So then we look at our next place value digit. We look at the 5 and the 7 together. And we ask ourselves, how many times does 22 go into 75? And we can plug around in our calculator, or if you're good with numbers, you can do this in your head. 22 goes into 75 3 times. Let me just get my writing to look nice. There we go. So 22 goes into 75 3 times. And then we multiply 3 times 22, and we end up with 66. And we subtract 66 from 75, and I end up with 9. We bring down the next place value. And now we look at this and we say, how many times does 22 go into 93? Okay, we do the same little process. We can do this on our calculator. We can do this in our head. We should get an answer of 4. 22 goes evenly into 93 4 times. 4 times 22 is 88. And we subtract 93, take away 88, leaves us with 5. And since we don't have any additional place values in the number 753, we stop there. And each of these pieces of this question have a different name. The number 753 is called the dividend. The number 34, the answer, is called the quotient. Promise my writing will get better. And the number 22 is called the divisor. And then the last bit of this question is what's left over. And that's really what we're going to be focusing on today. So in this question, when we divided 753 by 22, we got an answer of 34, but we also had a little bit left over. And the number 5 is something called the remainder. Because 22 doesn't divide evenly into 753, there's a little bit left over. And that's that number 5. So if I was to express this question a little bit differently, if I had 753 over 22, I could say this is equal to 34 plus an additional 5 20-seconds. Number 34 and an additional 5 left over. Now, our biggest challenge today is seeing how we can take this idea of long division with numbers and apply it to polynomials. So we want to divide a polynomial by a binomial. So let's take a look at how we can do that. Well, notice my question is the polynomial negative 3x squared plus 2x cubed plus 8x minus 12, and we're going to divide that by x minus 1. The first thing we need to do is rewrite our polynomial in order of descending power. So I'm going to rewrite my polynomial as 2x cubed minus 3x squared plus 8x minus 12. So I've written it in descending power, so the largest power is first and it goes down in order. And I'm dividing this by x minus 1. Okay, so I've set this up like a division question. Let's see how we can do this. I'm going to look at the binomial, x minus 1, and really the only part of the binomial that I'm concerned with right now is that value x. I'm going to ignore, for now, that coefficient of negative 1. So I'm concerned with the x, and I'm going to treat this similarly to our long division with numbers. I'm going to look at the number or the value x, and I'm going to look at the value 2x cubed, and I'm going to ask myself, what do I need to multiply x by to get 2x cubed? Okay, what do I need to multiply x by to get 2x cubed? And if I think about it, I need to multiply x by 2x squared. Notice how I've put that number above the term negative 3x squared. Okay, I'm lining up my place values. My next step is to take this value, 2x squared, and multiply it by the binomial. So if I multiply 2x squared by the binomial, I get 2x cubed minus 2x squared. And I'm going to subtract this new term from what's above it. So if I subtract 2x cubed from 2x cubed, I get 0. If I subtract 3x squared from negative 2x squared, I'm subtracting a negative, so I end up adding. I end up with negative x squared. And then just like in numerical long division, I bring down the next place value. I bring down the 8x. And then I repeat the process. I look at my binomial, I look at the first term in my binomial, and I ask myself, what value do I need to multiply x by to get negative x squared? And I'd have to multiply it by negative x. Negative x times x is negative x squared. Negative x times negative 1 is positive x. And then I subtract. The first two terms are going to cancel each other out. And then I have 8x take away x. So I end up with 7x. And I bring down the next place value, I bring down the negative 12. And again, what do I need to multiply x by? To get 7x, I have to multiply it by 7, positive 7. 7 times x is 7x. 7 times negative 1 is negative 7. I subtract. First two terms cancel each other out. Negative 12 take away negative 7 becomes negative 12 plus 7, which leaves me with negative 5. Sorry, I have no more terms to bring down in the dividend, so I'm done. If I wanted to express this properly, I would say that 2x cubed minus 3x squared plus 8x minus 12 over x minus 1, or divided by x minus 1, is equal to 2x squared minus x plus 7 minus my remainder of 5 over my divisor, x minus 1. This statement now is in a form called quotient form. I've stated my original question, I've expressed my quotient, and I've restated my remainder. Okay, so that's division of a polynomial by a binomial. So when we have a polynomial, and we'll call this polynomial p of x, and we divide it by a binomial that has the form x minus b, the result of this division, the result of p of x divided by x minus b, is equal to q of x, and I'll talk about what that is in a second. So the result is q of x plus r divided by x minus b. And here, q of x is the quotient, r is the remainder, and the statement p of x is equal to x minus b times q of x plus r can be used to check to the division. So what this is just simply saying that the polynomial p of x is equal to the divisor times the quotient plus the remainder. We can use that to check our division to see if the division's right. So let's just look at another example. Let's divide a polynomial by a binomial, and this time we have a different form. This time we're of the form ax equals b. So now in our binomial, the factor ax minus b, that value of x has a coefficient. So we'll set it up the same way. I'm going to divide this polynomial by 2x plus 1. And I write my terms in order of descending power, so 4x cubed. And I notice that I'm missing in my polynomial a factor or term raised to the power of 2. So I need to make sure that I add that in. I need a placeholder. So I add in 0x squared, and I continue plus 9x minus 12. This value of 0x is simply just a placeholder. Okay, we use it to make sure, just like as if we had the number 101, we need a 0 in the middle of 101 to hold that place. So we do this the same way. I look at my first term, I look at 2x, and I say to myself, what do I need to multiply 2x by to get 4x cubed? And I need to multiply it by 2x squared. 2x squared times 2x is 4x cubed plus 2x squared, and I subtract, and I end up with 0 take away 2x, so I end up with negative 2x squared. I bring down my next term, positive 9x. And I ask myself, what do I need to multiply 2x by to equal negative 2x squared? I need to multiply it by negative x. with negative 2x squared. Negative x times positive 1 is negative x. And I subtract again. 9 take away negative x becomes 9 plus x, or 10x. I bring down my next placeholder. What do I need to multiply 2x by to equal 10x? And the answer is just 5, positive 5. So 10x, 5 times 1 is just 5. Negative 12, take away 5 is negative 17. I started with 4x cubed plus 9x minus 12, and I divided this by 2x plus 1. And I found that this is equal to 2x squared minus x plus 5. Take away my remainder, which is 17 over my divisor, 2x, and my remainder of negative 17 over 2x plus 1. The question asked me to state any restrictions on the variable. My restrictions would be based on the divisor, 2x plus 1 cannot equal 0, because then I'd have a division by 0. If I solve this out, I see that 2x cannot equal negative 1, or x cannot equal negative 1 half. And then to answer part B, my corresponding statement that can be used to check the division would be stating that my original polynomial, p of x, so 4x cubed plus 9x minus 12, is equal to my divisor, 2x plus 1, times my quotient, 2x squared minus x plus 5, plus my remainder, negative 17. So my polynomial is equal to my divisor times my quotient plus my remainder. Okay, and this leads us to an interesting point, or our theorem of the day, the remainder theorem. If I have a polynomial p of x, and I divide it by this factor of x minus b, then the remainder would be the polynomial evaluated at b. And likewise, if I have a divisor that's a little bit more complicated, that has a coefficient in front of x, the remainder would be the polynomial evaluated at b over a. So let's take a look at the remainder theorem in application. I'm just going to do part A. We're going to use the remainder theorem to determine the remainder when p of x is equal to this function, when the polynomial is equal to this function. And I divide by x plus 1. So I'm not going to do the long division. I'm going to divide by x plus 1, which means that x would equal negative 1. So in part A, I'm going to evaluate the polynomial at negative 1. So I'm going to sub negative 1 in for my variable, and I'm going to solve this out to see what I get. I end up with negative 2 plus 1 plus 3 minus 6 Negative 2 plus 1 is negative 1. Plus 3 is positive 2. Take away 6 is negative 4. And if I was to do this division, I would see that I get a remainder of negative 4. Okay. Part B, which I said I'm not going to do, but I would set up, because I have this slightly different divisor, I could rearrange this so that 2x equals 3 and that x equals 3 halves. So to do B, I would be evaluating the polynomial at 3 over 2. You can try that on your own. And you should get a remainder of negative 3 halves. Okay, try that on your own and see if you get the right answer. So what you've learned today is how to divide a polynomial by a binomial using long division. And we've seen how we can divide by this divisor, and we can write this equation a few ways. We can use this statement to check the division, and we can also state the quotient a little bit more explicitly when we divide. There's a few ways to check the result, but most importantly, we've looked at the remainder theorem, and we're going to build on this in the coming weeks. The remainder theorem states that when a polynomial function is divided by a binomial, the remainder is just the polynomial evaluated at the constant value of that divisor. When you come to class, we're going to be taking a look at page 91, and we're going to try questions 1, 2, 3A, CE, 4A, 5, 7A, CE, 14AB, and 16. Bring your questions to class. I'll do a 10-minute recap, and hope to see you all on Monday. Thank you.